Good afternoon, everyone. I am Shreya and I am the TA for this course, one of the TAs for this course on data science with R software. And today I'll be discussing week 9 lectures and a few problems associated with week 9 lectures. Yeah, so before we get started with week 9 questions and problems, I would like to discuss what we learned during this week. Okay, so in earlier we had learned about distributions. All right, we had learned about uh, continuous distributions, we had learned about discrete distributions and various sorts of it. Like for example, if we were to talk about discrete, one second. Yeah, so previously we learnt about discrete random variables and we learnt about continuous random variables. Okay, in discrete we learnt about binomial, we learnt about Poisson, we learnt about geometric. In the continuous setup, we also learnt about discrete uniform. Okay, and there are a few others which we did not go into details. Actually, we didn't cover, but also we learnt about continuous random variables, and for them we learnt about the normal distribution. Then also we learnt about exponential distribution. Okay, these were the two primary, and also uniform distribution. Okay, primarily we learnt about these three. Yes, so now those were when only one variable was considered. It was a univariate case. Okay, so only, that is only one random variable, and that could follow either of these distributions. And then we also learned about joint distributions, conditional distributions, where, so then we learnt about some joint distributions, and then we learnt about continuous distributions. Okay, both in discrete and continuous setups. So for discrete setups, what we do? For discrete setups, we created the contingency tables, and from then we could get the marginals and the conditional distributions and so on. Similarly, for uh, sorry, not continuous, this should be conditional. So we learned about the marginal distribution, the conditional distributions from contingency tables, and also from uh, about, also we understood or learned how to derive the marginal and conditional distributions when both the variables x and y are, they could either be discrete or they could be continuous. So far we have learned this. Now, as a special case of bivariate continuous distribution, in week 9 we learnt about bivariate normal distributions. Okay, so bivariate normal, what is it? That is, x follows some normal mu1 sigma 1 square and y follows normal mu2 sigma 2 square, and these two are not necessarily independent. What does that mean? That there is some degree of correlation between x and y, and we learned how to write the PDF CDF, not CDF, but the PDF and the distributions. So just to brush up the concepts a little bit more, so this is an extension of normal distribution to two random variables. Okay, so what does the PDF look like? So the PDF can be specified, it can be parameterized by how many parameters? Actually it can be there can be 5 parameters. Okay, so PDF of x and y, and the parameters are sigma x, that is the standard deviation of the random variable x, sigma y, the standard deviation of the random variable y, okay, mu x, the mean of this distribution, random variable x, mean of the random variable y, and the correlation coefficient rho. Okay, and what are the ranges of these parameters? Sigma x has to be greater than 0, sigma y has to be greater than 0. Okay, mu x can be anywhere between minus infinity to infinity. Similarly, mu y can also range from minus infinity to infinity. And rho, correlation coefficient, it can only range from minus 1 to plus 1. Okay, these are the bounds and these are the, what do I say, these are the parameters of the bivariate normal distribution. And how does the PDF look like? So the PDF looks something like this. So fxy xy would be 1 by 2 pi sigma x sigma y into root over 1 minus rho square e to the power minus 1 by 2 1 minus rho square, and then we have x minus mu x whole square by sigma x square plus y minus mu y whole square by sigma y square minus 2 rho x minus mu x y minus mu y by sigma x sigma y. Okay, where the ranges hold, that is x can range between minus infinity to infinity, y can also range between minus infinity to plus infinity, and sigma x sigma y should be greater than 0. Rho should lie between 1 minus and minus 1 and plus 1. So so rho should be strictly between minus 1 and plus 1. Okay, and mu can range anywhere between minus infinity to plus infinity. Okay, so this is the joint distribution. Okay, or in other words we call it as a bivariate normal distribution. Okay, now if this is the joint or bivariate normal distributions, the marginal distributions are simply, so if I have to do marginal fx, this follows normal mu x sigma x square, and fy follows normal mu y sigma y square, and rho is the correlation coefficient between x and y. Alright, these are the marginals of that joint distribution. Now what about the conditionals? So conditional distribution can be written as f of y given x equal to x, y given x, and that follows a normal mu y plus rho sigma y by sigma x, x minus mu x, and sigma y square 1 minus rho square. Okay, and similarly f of x given y equal to y, x given y follows a normal mu x plus rho sigma x by sigma y, y minus mu y, sigma x square 1 minus rho square. Alright, and how can we write the covariance between x and y? Can be written as rho into sigma x into sigma y. Okay, where rho is the correlation coefficient. Alright, now if I can see here, if rho is 0, then we can split it into two parts. This part will become 1 and this will also become 1, and this cross product term will vanish. Then if we rearrange, then we can rewrite it as fxy xy equal to f of x and f of y. Alright, so if rho is equal to 0, then we say x and y are independent, and then we can write fxy x comma y as fx of x into fy of y. Alright, so this is the parameterization for a bivariate normal case. So it can be extended to a multivariate normal case. Okay, so in such cases we could have, let's say, x1 x2 xp are p normal variables, okay, with their means as mu1 mu2 mu p and variances as sigma 1 square, sigma 2 square, sigma p square. These are the means of these p normal variables, and these are the variances of these p normal variables. Alright? Okay. Okay, so then writing it down in one line is difficult. So what we usually do is we use a matrix notation. Okay, so how do we represent this p variate normal distribution? So we write it in terms of a vector. Okay, so let's say this is a p cross 1 vector. So this is x1 x2 and xp. Alright, and mu is the mean vector, that is also a p double vector with mu1 mu2 and then mu p. And sigma is a p cross p matrix, which is called the variance covariance matrix. Okay, so if this is this, then on the diagonals we will have the p variances, and on the off diagonals we are going to have the covariances. Okay, so sigma 1 2, sigma 1 3, sigma 1 p, sigma 2 1, sigma 2 3, sigma 2 p, and then here again sigma p1, sigma p2, and then sigma p square. Okay, so this will be the covariance matrix. Alright, we can write covariance of x equal to sigma. Okay, and this has to be positive semi-definite and non-singular, and also the off diagonal elements are equal. So sigma 1 2 equal to sigma 2 1, that is, this is also a symmetric matrix. Okay, so these are the properties. Now uh, if we have to simulate or generate such multivariate or bivariate distributions from R, then how are we going to do it? We are going to use the package MVT norm. Okay, so let me go to this R console. Alright, so alright, so in order to do that, we need this package called MVT norm. So we should of course install this package, and then after calling it, let's say if we want to generate two samples from a bivariate distribution with means 10, 20 and sigma is C23. So what does this essentially mean? If this is the case, how am I going to, one second, alright, okay, so hello Mr. Sunil, I am just explaining how we can translate the multivariate normal parameters to R. Alright, so if can you see my screen?
Yes, ma'am.
Okay, so here let's say this is the command that I am using. RV norm n equal to 2, mean C 10 20, sigma diagonal C23. Then what is it exactly that I am generating? Alright, so this one is going to give me some output. The output is given below. Okay, so this is what I got from so this is what I got, okay, from my R console using this command. So what it essentially is doing is that it is generating two so it is generating two samples. This is the first sample, okay, and this is the second one. Alright, so how are we actually generating this? Let's say we have x1 and x2. So x1 follows normal 10 and sigma is 2. So 10 2, mu 1 mu x sigma x square. Alright, and x2 follows normal 20 and sigma y square is how much? 3. Okay, so it is generating x11 x21 and x21 x22. Okay, so the first sample was this one. This is your x11 x21, this is x12 x22. Okay, so if instead of 2 if I give 3, then I am going to have x13 x23. So similarly, if I want to generate n random vectors, n random vectors, so the rows would give me the combinations of x1 and x2. So this is my variable x1 and this is my variable x2. Alright, is it okay? Fine. So if I want to know more about this package in R, So where was I? So yes, if I want to know more about this package, I am going to press Ctrl F1, and here this help page will open with multivariate normal densities and random deviates, and we could just use these to find out whatever we need. Alright. Okay, DMV norm is going to give me my density function, and RMV norm is going to generate the multivariate normal distribution. So this was all about bivariate normal. So let us solve a few problems with respect to bivariate normal, and then we'll be back to our course. Okay, so suppose this is your okay, before I move on to question and answers, is there anything that you would like me to discuss, any doubts in previous assignments, previous sessions? Please tell me now if you want me to discuss something. Okay, so if nothing, then I'll just proceed. So let's say we have the joint bivariate normal distribution with probability function given like this. Okay, and we are to find out what are the means of x and y. So in order to do that, what will we first try to understand? We'll first try to map it with the standard form of a bivariate normal distribution. So a bivariate normal PDF looks like this: 1 by 2 pi sigma x sigma y root over 1 minus rho square e to the power minus 1 by 2 1 minus rho square. Then we have x minus mu x whole square by sigma x square plus y minus mu y whole square by sigma y square minus 2 rho x minus mu x y minus mu y by sigma x sigma y. So from here, what we can write, we can see that this form x minus mu square y minus mu square plus 2 into 2 rho into x minus mu into mu x y minus mu y. So from here we can readily observe that in the denominators nowhere mu is appearing, only sigma x and sigma y are appearing. Mu x is appearing where? Only in the numerators, and it is matching with this format that is being provided. Alright, so then from here easily we can find out mu x is 2 and mu y is 4. Okay, alright, this part is, I hope, clear. Now if we are asked to find out sigma x and sigma y, then how are we going to find it out? Okay, same question, we have been asked what are the standard deviations of x and y. So let me just write this down again once more. So we have 1 by 2 pi sigma x sigma y root
Can
over,
we have a look for first question?
yeah, where is your doubt?
What is mu y position here?
Mu y position is here. So if you remember the PDF, right, bivariate normal?
Yes, ma'am.
Okay, so it looks like this. Here let me just go back to this slide. This is how it looks like, the PDF. Okay, 1 by 2
Okay.
pi sigma x sigma y 1 minus rho square, and then 1 by 2 1 minus rho square. This is the form x minus mu x whole square by sigma x square plus y minus mu y whole square by sigma y square minus 2 rho x minus mu x y minus mu y sigma x sigma y. Okay, where if x follows normal mu x sigma x square, y follows normal mu y sigma y square, and they are correlated with rho. This is the setup.
Okay.
Alright, so here we have to match the parameters with this form of the distribution. So as I was saying in question number 1, here you see all mu x's and mu y appear in the numerator, and that too within the exponential thing. Okay, so if we have to write here, x minus mu x square is x minus 2 square, y minus mu y square is y minus 4 whole square, and then we have x minus mu x into y minus mu y as x minus 2 into y minus 4. So from here we can see that since the denominator, nothing is involved in the denominator, like the denominators doesn't involve mu x and mu y, so we can straightforward deduce that mu x is 2, mu y is 4. Alright,
Okay.
so let's say here if you were given something like this x minus 2 into y minus 4, it's how much? This is x square, uh, no, this is, let's say if something else was given over here, x minus 3 into y minus 4 or something, then we couldn't have done that mu x is 2 and y is 4 that straightforward. Okay, but since this is matching with the parameterization, we can directly write mu x equal to 2 and mu y equal to 4. Is it clear now?
Clear, ma'am.
Okay, sir. Alright, now this is clear, this was straightforward. Now what if you are asked about the standard deviations? So I'll just write the format over here once again. We have exponential minus 1 by 2 1 minus rho square, then we have x minus mu x whole square by sigma x square plus y minus mu y whole square by sigma y square minus 2 rho x minus mu x y minus mu y by sigma x sigma y. This is the parameter. So from here if you see, we can write that 2 pi sigma x sigma y into 1 minus rho square is equal to 15 pi. Alright, is this clear? This is matching with 15 pi. Also here what do we have? Here we have minus, if we take common, then 1 by 2 into 1 minus rho square into sigma square, this is equal to 2 by 9 sigma x square. Is it okay? This part should match with this part, right? So similarly we can write this as, so this is another equation that I have. Similarly 1 by 2 1 minus rho square sigma y square is equal to how much? It is 2 by 25. Okay, and here if I write another equation, that is 1 by 2 1 minus rho square into 2 rho by sigma x sigma y. This part is actually 2 by 9. Alright, so these are the three equations that I have. From here I have to solve for sigma x, sigma y and rho. So what are the three equations that I have? This is 2 pi sigma x sigma y root over 1 minus rho square is 5 pi. Okay. Another equation is 1 by 2 1 minus rho square into sigma y square is how much? 2 by 25. 1 by 2 1 minus rho square sigma x square is 2 by 9. Okay, and also we have this one 1 by 2 1 minus rho square 2 rho by sigma x sigma y is equal to 2 by 9. Okay, so solving all of these, we will be able to find out sigma x and sigma y. This is just one way to look at it. The next thing is so if we just solve this, how much do we get? So from here we can write 1 minus rho square is equal to 5 by 2 sigma x sigma y whole square. Okay, so this is 25 by 2 sigma x square and sigma y square. So substituting here, what do I get? 1 by 2 into 1 minus rho square is how much? 25 by 2 sigma x square sigma y square into sigma y square equal to 2 by 25. So this 25 cancels. So if I go here, sigma y square, it is 25 by 2 into 2, 25 by 2, 2 into 25 into 2 sigma, sorry, this sigma y square cancels, right? So and this 2 cancels, so we have sigma x square by 25 equal to 2 by 25. So then sigma x square will be 2. Alright. Okay, I'm coming to z chi-square and those things. Okay, so is this clear? Then So from these equations, okay, so sorry, this will be 25 by 4. One second, extremely sorry.
We have to find out the value of sigma x and sigma y, right?
Yeah, you have to find out value of sigma x and sigma y. So this one we have taken. This equation is also 2 by 9. Alright, this is also 2 by 9. One second, 2 by 9. Okay, so 1 minus rho square is how much? 5 by 2 whole square by sigma x sigma y whole square. So then 1 by 1 minus rho square would be 4 by 25 sigma x square sigma y square. Sorry, this would be 4 sigma x square sigma y square by 25. So substituting here, we would get 1 by 2, 1 by into 1 minus 1 by rho square will be 4 into 25 sigma x square sigma y square by sigma y square equal to 2 by 25. So then this cancels. We have sigma x square equal to 1. Alright, and then again from here we'll solve this one. 1 by 2 1 minus rho square into sigma x square, this would be 2 by 9, and then we would just substitute 1 by 2 here. 1 by 1 minus rho square is 4 by 25 sigma x square sigma y square by sigma x square equal to 2 by 9. So sigma x cancels, this 2 and 2 cancels, so sigma y square would be 25 by 9. So sigma y would be 5 by 3. Alright, and then rho would be how much? If we have sigma, so sigma x was 1, sigma y is 5 by 3. So then rho would be how much? Rho would be, so 1 minus rho square is given by 25 by 4 sigma x square sigma y square. So 1 minus rho square will be 25 by 4, sigma x square is 1, sigma y square is 25 by 9. So this would cancel. 1 minus rho square would be 9 by 4, then rho square would be 1 minus 9. No, something is off here, some calculation mistake I'm doing. Rho square can never be negative. These equations are right? 2 pi to sigma x sigma y root over 1 minus rho square is 15 pi. This is correct. Okay, this is 15 pi. So there I've made a mistake. Alright. We'll just remove this and do it afresh. So 2 pi sigma x sigma y root over 1 minus rho square is 15 pi. Again this one 1 by 2 1 minus rho square into sigma x square is how much? That is this coefficient of x minus 2 whole square. So that would be 2 by 9. That's the same thing I have written. Yes. Again 1 by 2 rho square is sigma y square should be coefficient of y minus 4 whole square. So that is 2 by 25. And again this minus stays here. So 2 rho by 2 sigma x sigma y into 1 minus into 1 by 2 1 minus rho square, it is the coefficient of this cross product term, that is 2 by 9. Alright, so from here we can write it 2 pi sigma x sigma y into root over 1 minus rho square is 15 pi. So this implies that sigma x sigma y root over 1 minus rho square is 15 by 2. So 1 minus rho square would be 15 by 2 sigma x sigma y whole square. Okay, so then now substituting it in this equation, 1 by 2 1 minus rho square sigma x square, that is how much? That is 2 by 9. So then this is, we can write it as sigma x square equals to 9 by 4 into 1 minus rho square. So this is 9 by 4 into 1 minus rho square is how much? 225 by 4 sigma x square and sigma y square. So 4 cancels, sigma x square sigma x square. One second. Something is wrong with me. So if I write from here 1 minus rho square into sigma x square, this entire thing is nothing but 225 by 4 sigma y square. Okay, so if I substitute here, I can write half into 225 by 4 sigma y square equal to 2 by 9. Alright, so this 2 cancels, 2 here also cancels. So sigma y square would be 225 by 9, sigma y would be 5 by 3. Alright, and then the next one is the same thing, 1 by 2 into 1 minus rho square sigma y square, that was equal to how much? 2 by 25. 2 by 25. And from here we can also write 1 minus rho square sigma y square equals to 225 by 4 sigma x square. So substituting, what do we have? 1 by 2 into, here we have 225 by 4 sigma x square equal to 2 by 25. So 2 here cancels, sigma x square equals to 25. So then sigma x equal to 5. Alright, so now if sigma x is 5, then what is the value of rho? Rho would be so then it is we can write this like 1 minus rho square equal to 15 by 2 sigma x sigma y. 15 by 2
Excuse me, ma'am.
yes.
Ma'am, I think sigma y would be 15 by 3, that is equals to 5 instead of 5 by 3. There is some calculation error.
Sigma y?
Yes, ma'am.
Okay, sorry. Yes. It would be 15 by 3. Yep. Thank you. This is 15 by 3 and this is this will also change, right? This would be 225 by 25. So if I go 15 into 15, this is 5 and this 5 4s are 20, 45. So this would be 9. So sigma x will be 3. Is it okay? Sigma x is 3. Sigma y is how much? One second.
Sigma y would be 5.
Sigma y would be 5.
15 by 3, that's 5.
Yes.
Ma'am, is it just a coincidence or like we can directly get it from the by comparing through the standard form?
We can directly get it through standard form, but it is better to what do I say? To do it in this way, because the problem will lie in this term. If this is not that straightforward, it is difficult to, like, if this is not something entirely square, this is a coincidence that we are getting something x square and y square, and then in that format is being maintained. But suppose you had something 8 over here or something 6, let's say. So 2 instead of 2 by 9 you had here 6 and or let's say 3, something like this, and you had 2 by 3 over here. So then it is not that straightforward. My advice would be to form these equations and then deduce the values, and also to check whether the conditions are holding or not. That would give you increased confidence on your calculations. Like when I was making a mistake, I calculated rho square to be something negative, so that shouldn't also happen, right? Okay, so then if I am asked what is 1 minus rho square, what would I write? One second. Is it not working? Excuse me. So then root over 1 minus rho square would be 15 by 2 sigma x sigma y. 15 by 2 sigma x sigma y. Sigma x is 3, sigma y is 5. Yeah. So this is 3, this is half. 1 minus rho square is 1 by 4. Rho square would be 3 by 4 and rho is root 3 by 2. Okay, root 3 by 2 is within is less than minus 1. Sorry, less than 1. SQRT 0.866. So that's okay. Now we can go back and check with this form. Alright, so this one, sigma x square 3 square, it's matching. Sigma y square 5 square, that is also matching. And this one should be 2 rho by sigma x sigma y. Okay, so 2 rho That is how much? 2 into root 3 by 2 into sigma x and sigma y. Sigma x is 3, sigma y is 5. So is it coming here? One by two, something here. 1 by 2, 1 minus rho square is how much? 1 by 2, 1 minus rho square is half. That is 2 into half square. So we are getting 2. So this part is matching. Now only query that remains is that this thing, okay? So it should be 1 by 9, 2 rho by sigma x sigma y. So 2 rho by sigma x sigma y should be 1 by 9. Is this holding true? So maybe rho is root 3 by 2, right? So 2 into root 3 by 2 into 3 into 5. That is not coming equal to 1 by 9, or did I do some calculation mistake? Maybe there's some typo over here. This should be something else. No, but we reduced it from here itself, right? Or did we not use this equation? We think we haven't used this. No, we have not used this equation. So I think there's some typo over here. Alright. Okay. So just be careful about these coefficients and try to solve it with equations instead of just purely eyeballing and guessing, because that might end up in trouble. Alright, it has to satisfy all the equations. Like here, as I'm seeing, I think that there is some problem over here.
Actually, I think that there isn't any problem.
There isn't any problem. Okay, so maybe I'm making any mistake. Can you point it
Ma'am,
out?
we have to include the -2 as well, no? And the term that is outside the bracket, exponential raised to the power -2. If you
Huh.
will include that, then the answer will come correct.
That I'm including, right? So this -2 is actually equal to 1 by 2 into 1 minus rho square.
Yes, ma'am.
That is true, right? So then this part should be equal to 1 by 9. Here what I did was I included this coefficient and the coefficient of x minus 2 into 1 minus 4, that is 2 rho sigma x sigma y, and then that was equal to this one and this one by this one. Maybe I'm confused. So even if we include this, is it holding true? This equation, let's say.
I tried with the sigma x square,
Hmm.
so it's holding true, but it
Yeah.
is just not working with the last term.
That's what I'm saying. So sigma
Yes,
x
ma'am.
square, sigma y square, these are holding true, but this one it's not working.
Yes, ma'am.
So we do have standard deviations x and y, but there's some typing error or some error in this part. Alright. So that we have to be very careful about. If you find, so if you do not see and cross check with all the equations, you won't be able to identify such problems. So I would request you to do it in this manner, alright, instead of just looking and taking a guess. Alright, so this is done. Now,
Ma'am,
yes,
in the exam, how will we find the value of z, chi-square test, etc. without the table?
without the table, see, in the exams, either you would be provided with some values, without that, or you would be provided with a table. So from there you can find out.
Like the table will be on the computer itself or a physical table, or
uh,
we have to bring our own. Matlab,
I
like
don't
there
think
should
you
be
have
some
to
clarity.
I don't think you have to bring your own. The values and critical values should be provided to you, but it should be available on the screen, actually. So, but I would request you to get this confirmed with the NPTEL team. You just put a mail to that support group, and they would tell you what the final format of the examination would be like. Okay. But if you need to find out critical value, something or the other would be provided. Some hints or tables or some values. This should be provided.
Okay, ma'am.
Okay. Alright. So here is the same question. Just ignore this part. This should be something else. Alright. Okay, sir. So if I have to find out values of expectation of x given y and variance of y given x. So x given y, sorry, x given y, it follows a normal with the parameterization. What is that? That is mu x plus rho into sigma x by sigma y and then we have x minus y minus mu x. Okay, and the variance would be how much? The variance would be sigma x square into 1 minus rho square. Alright, so mu x we know is 2, mu y we know is 4, sigma x is 3, sigma y is 5, and rho is how much? I just want to ensure that I'm not making any mistakes in the calculation of rho. This is fine, right? 2 pi, so 1 minus is 15 by 2. So 1 minus rho square is 15 by 2. So rho square would be 2 sigma x sigma y. Alright, fine. We'll see what happens. Mu x, mu y, sigma x, sigma y, we know, and the value of rho also we know. Alright, so rho was for us, it was root 3 by 2. So we'll just substitute, and this value, this term would give me expectation of x given y. Whatever is the answer, that will be the case. Alright. Similarly, variance of x given y, variance would be sigma x square into 1 minus rho square. So this I know, this is 9 into 1 minus rho square was half. Nothing. Okay. So anyway, this is not matching with either of these.
Ma'am, rho is coming out to be root 3 by 2. So sigma x square 1 minus rho square should come out to be 9 by 4.
Sigma x square 1 minus rho square, no? So 1 minus rho square is 9 by 3
3
by
by
4.
4. So it should be 9 by
this
4.
is 9 by 4. Yes, sorry. Anyway, it's not matching with either. Whatever it is, just be careful with the calculations. This one and this part you would get from this equation. Now similarly, if you were asked expectation of y given x and variance of y given x, then you just have to replace this with the x's with the y's, and that's it. Alright, whatever is given, that sigma will come in denominator, and that will come here as given thing minus mu of the given thing. Okay, and whatever we want, that sigma square will come in the numerator of variance. Just note this pattern and you're good to go. Alright. Okay.
Ma'am, do you have any idea how many questions are going to be there in the exam?
I don't have a any idea on the number of questions, but it will be a 3-hour duration. So, and everything will be MCQ, so you can imagine.
Like, because it is mathematics, so it is going to be like finding values is lengthy. It's a lengthy process.
But I don't believe that lengthy problems will be given to you. I don't have any idea on the number of questions. Sorry. Alright. So here again, expectation of y given x, variance of y given x. Same thing, y given x follows normal, and this would be mu y given x. So mu y plus given x, so x will be down, sigma x, sigma y, x minus mu x, and sigma y square 1 minus rho square. Now you know rho, you know sigma, you know sigma x. Just plug in the values and you would get this. Alright? Okay. Let's say this one. If x and y have a joint normal distribution with probability function as this, which of the alternative is true for the marginal distributions of x and y and conditional distributions of x and y? Okay, Marginal distributions are always normally distributed. Conditional distribution are not necessarily normally distributed. This is false. It is given it is a bivariate normal distribution, then the marginals are also normal and conditional is also normal. So wherever both are written, that will be true. Marginals as well as this one. Marginal distribution as well as conditional distributions are always normally distributed, irrespective of whether rho is 0 or rho is anything other than 0. Alright?
Yes, ma'am.
Alright. Okay, sir. So let's move on to this question. Okay, so now we have x and y to be jointly normal random variables with parameters these. So we have to find probability 2x plus y is less than equal to 3. How will we do that? Let us assume z equal to 2x plus y. So now this is a linear combination of two normal variables. So this will also follow a normal distribution. Okay, this is one point, that is linear combination of normal will also follow a normal distribution. Okay, so z follows normal. What is the mu? Mu would be expectation of z and sigma square would be variance of z. Okay, now expectation of z, what can we write this as? This is expectation of 2x plus, expectation of 2x plus y. So this would be expectation of 2x plus expectation of y. This we can write as 2 into expectation of x plus expectation of y. Okay, so this will be 2 into mu x plus mu y. That is how much? Mu x is 1, mu y is 0. So this will be 2. Okay. Now, next comes what is the variance. Okay. So here variance of z is how much? Variance of 2x plus y. So this we will write as variance of 2x plus variance of y plus 2 covariance of 2x and y. Okay. So this one we will write as 4 into variance of x. Since it is variance, the constant will come out with a square, plus variance of y plus covariance of 2x and y will be 2 into 2 of covariance xy. Alright. So this will be 4 sigma x square plus sigma y square plus 4. Covariance of xy will be rho sigma x into sigma x square, sigma x into sigma y. Okay, so we'll just substitute over here. Sigma x is how much? Sigma x square is 1. So here we have sigma x square is 1, sigma y square is 4, and rho is 12. So here it will be 4 plus sigma y square is 4 plus 4 into 12 into 1 into 2. So this will be 8 plus 48 into 2, that is 96. Alright. Four into 12 into 1 into 2. Alright. So then this is 96 plus, what will this be? Whatever it is, 404. This is the variance. Alright. So this is the variance of y and variance of z. Then z is following actually a, so here we can write then z follows a normal. Mu was how much? Mu was 2 and sigma square was how much? This is 104. Alright. Then probability z, what is, do we need? Less than equal to 3. This how we'll calculate. For this we'll write p norm, will give the value 3, mean will be 2 and SD will be square root of 104. Whatever is the answer, that is probability z less than equal to 3. Alright. So the next thing is find covariance between x plus y and 2x minus y. So this is covariance between x plus y and 2x minus y. So for this thing we just have to split the terms. So this is actually covariance between x 2x plus covariance between y 2x minus covariance xy, this into this, minus covariance y of y. Okay. So this 2 is going to come out. This covariance x and x is actually variance of x. So 2 variance of x plus covariance 2 covariance of xy minus covariance of xy minus variance of y. Alright. So this will be 2 of variance of x plus covariance of xy minus variance of y. So that would be 2 into sigma 1 square, that is 1, plus covariance xy is how much? That is rho into sigma x sigma y minus variance of y is 4. So same thing, 2 plus rho is 12 into 1 into 2 minus 4. So this will be 2 plus 24 minus 4, that is 22. Alright. Is it okay? If you are given some such composite things, you would be able to find out the evaluate the expressions, right? Alright. And then the third one they are saying, I hope this was clear, is it? Any doubts?
No, ma'am.
Okay, fine. So then if you are given something like this, find probability y greater than 1 given x equal to 2, then you would know what to do. How would you do it? You are asked probability y greater than 1, y greater than 1 given x equal to 2. So then just get the distribution of y given x. Y given x will also follow a normal. This would be mu y plus rho sigma y by sigma x, x minus mu x, and sigma y square 1 minus rho square. Okay, so then given x equal to 2, we are just going to supply this value with 2. So then what it becomes, when x equal to 2 follows normal, mu y was how much? Mu y was 0, so we need not bother. Sigma y was 2, rho was 12 into 2 by 1, 2 minus mu x was how much? Mu x was also 1. Sigma y square is 2, and 1 minus rho square. Oh, okay. Rho cannot be 12, it should be 1 by 2. I'm sorry, must have missed this one. Sorry, extremely sorry. This would be 1 by 2, because rho has to lie between minus 1 and 1. It cannot exceed 1, right? So just this was a typo from my end, extremely sorry. So here then rho, the value of rho would change. Yes, so 4 into half into sigma x is 1, sigma y is 2. So this would be 8 plus 4, that is 12. So then this would follow a normal 12. This would be square root of 12. Alright. Similarly here, this would be half. So then what do we have? Here this covariance term would be something negative. 2 plus 1 minus 4, this would be minus 1. Alright. Okay, then here this would be 2 into 1 minus half square. So that would be normal 24. 1 minus 1 by 4 is 3 by 4. That is 3 by 2. Sorry, this would be sigma y square, right? So this is 4 into 1 minus, so 4 into 3 by 4, this would be 24 3. Okay, so y given x would follow normal 24 3. Then probability, the required probability y greater than 1 given x equal to 2. In order to get that, we have to do a p norm 1. Mean would be whatever is the mean. Okay, so here also it will change. It is going to be rho is half. So this is normal 1 3, right? Yes, so this will be mean equal to 1, SD equal to SQRT3, and also another important thing, lower dot tail equal to false, because if we don't give that, by default it is going to give me probability y less than equal to 1 if lower dot tail is true, which is the default settings. All right.
Yes, ma'am.
Okay. Thank you. Fine. So next. Okay. So these are the types of questions you might expect. So probability chi-square 15 less than equal to 25. It something if you get something like this, then our obvious choice is p chi-square, and lower dot tail would be true. That is what you want. You have to provide the boundary and the df. That's it. Okay. So the r command is this thing, and whatever you get using this r command, that is your answer. Okay. So I'll just show you one. Let's say p chi-square, it should be less than or equal to 25. Okay. Q equal to 25, df equal to 15, and lower dot tail should be true. This is 0.9500566. Alright. Now I would like to ask you, do you know how, if suppose the software is not available to you, then how, and the table is available, then do you know how to read a chi-square table and how to do that?
Ma'am, it would be better if you could
Okay. Okay. So
have some basic idea, we say.
Alright. So just my entire screen is visible to you, right?
Yes, ma'am.
Okay. So just type chi-square table, distribution table. Whichever you get, just open it. Usually the chi-square table that you are given, this usually gives you the upper df. Okay. So this is the area above which these many percent one second. Yes. So what usually is given to you in the form of a table is this shaded area. Alright. So for example, in our case, we needed df 15. So let's go here. Okay. So if we wanted chi-square 25, right? What was the value that we wanted? Probability chi-square 15 is less than or equal to 25. Now let's say instead of 25 we are given one second. So
Hello. Yes, ma'am.
hello, yes.
Yes, ma'am. My line.
Do you have any specific queries?
Yes, ma'am. No, ma'am. I'm late. Only
Oh,
late
alright.
join.
Okay.
Okay.
Okay, fine. Thank you for joining. Alright, so where was I? Okay. So here what essentially you are given are these cutoff points. Okay, so let's say this thing 0.004. What is this? This is that point above which 95%, above which the shaded area is 0.95. Okay, so if I have to draw a parity over here, let's say I want probability my chi-square 15 greater than what value is equal to 0.95. Alright, so if I have to find out this thing, what I'll do, this is 1 minus probability chi-square, or rather I'm going to write down q chi-square 0.95, then I'm going to specify the df equal to 15 and lower dot tail equal to false. So let us just try this out. Okay, let's say q chi-square 0.95 df equal to 15 and lower dot tail equal to false. So what I'm getting is 7.26. okay, here. So if we go to the table now, our df is 15. So you see this value, can you see it? Is it visible? This one, this highlighted thing. So what it essentially is giving me, this table, is that the point, so you can see this shaded area, right? So the elements in these tables represent those points, and the area, the shaded area, is represented by these chi-square points. So for example, in our case 7.261 would be somewhere here, okay, or let's say here. How do I just write it? Okay, so let's say I'll draw it here. Okay, so this point is 7.261 and above this point 95% of area lies. Okay, and this thing is given by chi-square 0.95. okay, so this, if you see something like this, chi-square 0.95, it means that point above which 95% area lies. Is it okay? Now let's say if you have to find out probability chi-square less than chi-square 15 less than what would be equal to 0.05. So then it's the same thing. We will just use 1 minus chi-square 15 greater than which point equal to 0.05. So probability chi-square 15 greater than which point is 0.95. This point we will look in our table, and then the corresponding df, and then whatever that value is, that would be our x. Is it okay? So for example, let's say if I want to find out probability that chi-square 6 greater than x equal to 0.025. Suppose this is what I want to find out. Then this means I have to find out 0.025 and then df6 from that table. So if I have, you see here, chi-square 0.025, this is this point, and the df is 6. So my answer would be 14.449. So x would be 14.449. If I have to cross check, I can go to my software and I'll check p chi-square. P chi-square is going to give me my area. Q chi-square is going to give me that point above which or below which that certain area lies. So p chi-square 14.449, df equal to 6, and lowered dot tail equal to false. See, I'm getting 0.025. So what this essentially chi-square table is giving you, these are the points above which this area lies. Alright. Chi-square 0.025 is the upper 0.25% area. Is it clear to you how to read a chi-square distribution table? So these questions, if you get questions like this, let's say something you are given, probability something, some z less than something is given to you, and this should be greater than equal to 0.95, or some chi-square is given, what would be the bounds so that this probability is great, at least 0.95. Okay, so then accordingly you have to get these answers. Am I making sense, or is it completely, are you completely confused? Please tell me.
हम बेसिकली जो टेबल है
हम्म,
वो पॉइंट के आगे का एरिया बताती है.
राइट साइड का.
ओके.
One thing you have to note is that ये वाले जो entries है, this is not giving you the area. The area is given by this thing. So what it is essentially saying is that if you have a chi-square 2 distribution, then 0 x-axis में 0.051 अगर है तो उस पॉइंट के राइट साइड में जो एरिया शेडेड पोर्शन अगर मैं शेड कर दूं तो दैट एरिया विल बी 0.975. The area is actually given by these terms, shaded area. Okay, 0.1, 0.05, 0.25. और ये टेबल के एंट्रीज आर गिविंग यू द पॉइंट्स like it is mentioned over here. Is it okay?
Yes, ma'am.
All right. थैंक यू सो मच सर. So
हम
this
एक
is
बार ये भी बता दो कि
हाँ.
इसकी डिग्री ऑफ फ्रीडम कैसे कैलकुलेट करते हैं.
Degree of freedom. mm, calculate matlab what do you exactly mean by calculate?
I'm like, how will we know what value we have to search for if we don't know the degree of freedom? We have to find degree of freedom by some means.
Yeah, all right. So okay, so let's say if you have a standard normal variable, okay, then x square would be actually a chi-square with degree of freedom 1. Okay, but let's say degrees of freedom, actually it implies the number of independent values that you can take. So for example, let's say if I do x1, x2 and xn, all are normal 0 1 and all are independent. Okay, then x1 square plus x2 square plus xn square would give me a chi-square n. Okay, these additive properties hold. But let's say here, if you have sample variance, that is calculated as 1 by n minus 1 summation xi minus x bar whole square. Now here you see, if I have 10 xi's, here I am making I equal to 1 to n. So n xi minus n such xi minus x bar terms I am adding up, right? So and the context is given, xi's are all normally distributed. So now you see what happens. Here we are taking sum over n squared terms. Technically this should also follow a chi-square n. Okay, some transformation n minus 1 x square by sigma square something, this should follow a chi-square n. But this is not happening because if you have n x's, let's say summation xi minus x bar, it will always be 0. So this is one restriction that you have. So in that case, this distribution would follow chi-square n minus 1.
So, ma'am, can we say that for a population, it is going to it will be having n degree of freedom, and for a sample, it is going to have n minus 1 degree of freedom?
Yes, in some sense we can say that. There would be cases where it might be less than n minus 1 also, if you have additional restrictions imposed. Okay, so actually what it is that if you have a standard normal variable and the square of that is a chi-square 1, and then the additive properties hold. Okay, this much if you know, this would suffice. But then if you have to find out the sample mean or sample standard deviation, let's say this one, s square this one is sample variance, this would follow a chi-square, like some transformation, not exactly this, n minus 1 s square by sigma square would follow a chi-square n minus 1. Alright?
What is the significance of this, the term that you are writing in the bottom, at the bottom?
Significance,
Like मतलब use क्या है, कहाँ पे use है?
use है इसका. Suppose you want to find out, okay, हाँ, s square can be determined from the sample, because you know x's, we'll be able to calculate x bar. S square is a known quantity. Alright, n minus 1, okay, can be determined. Now if the question is such that what is the confidence interval for sigma, 95% confidence interval for sigma. So what I mean to say is that what should sigma lie between, so that this probability is 0.95. This is your question that you want to answer. In such cases, this distribution is very, very significant, because if we know that n minus 1 s square by sigma square follows chi-square n minus 1. Let's say I have 11 data points, okay, and s square is something around 10. Sigma square I don't know. Chi-square 10, I can see this follows a chi-square 10. So n minus 1 s square by sigma square follows a chi-square 10. So chi-square 10 would look something like this.
Chi-square 10 or chi-square 9?
N was 11.
Okay.
So chi-square 10. Okay. So this is 10 into s square. Also I took something. What did I take s square to be? S square is also 10. So let's say 100 by sigma square follows chi-square 10. So this is how a positively skewed chi-square 10 distribution looks like. Alright. Now, if I have to find out this thing, chi-square probability 100 by chi-square less than, let's say, chi-square 0.0975 and chi-square 0.025. This probability is 0.95. Do you agree with me? Sorry, this one I'll write as 0.0975 and this one I'll write 0.025. So this point is chi-square 0.025. This area is 0.025. And this point is chi-square 0.0975, such that this lower area is 0.025. You got the notation, right? Chi-square 0.025 means the point above which 2.5% of the data lies. So this area is actually 2.5%. And this is chi-square 0.0975 is that point above which 97.5%, 0.975. So this is that point above which 97.5% of the observations lie. So below which 2.5% of the observation lies. So if my chi-square variable is falling between these ranges, then this area which is unshaded, that would be 95%. That corresponds to this confidence interval. Okay, so the 100 by sigma square thing should lie between here and here. Now we can get the values of this directly from the table. If we just do a transformation, then we can write it as sigma square is less than 100 by chi square 0.025, and this is less than chi square 0.975. This probability would be 0.95. So this 100 by this point and 100 by this point is actually giving you a confidence band for sigma square to lie. That if sigma square lies between this value and this value, then we can say with 95% confidence that sigma square actually lies between these two values. Where is that my cursor? Can you see it? So this one and this one. In scenarios like this, this form of the equation or this sort of parameterization is extremely helpful. Did you understand even a little bit?
Yes, ma'am.
Please tell me if you have confusion. I'll explain again. So such
It's clear, ma'am.
It's clear. Okay, fine. Thank you. So such transformations and sampling distributions are usually used to determine for testing of hypothesis and to determine such confidence intervals. Okay, because these follow a certain kind of distribution, if we just can find the cutoff points for these known distributions, then we know that this transformed variable actually falls between this area and this area with this much of confidence. So then we can just rearrange and get a confidence interval for these things. Also for testing of hypothesis also we think this is very important. So let's say if you have something like this, okay, and some hypothesis, your test statistic is something like this. Under H0 your sigma has to be known. So then if it is too extreme on either of the ends based on the question under consideration, we can design our rejection rule and rejection area. I think we'll come to that in subsequent classes, but these are the use cases of such sampling distributions. All right. Okay, so we just do this. Okay, so here is another example where the experimenter is attempting to locate a target in 3D space, and 3 coordinates of the points chosen are independent normal random variables with mean 0, standard deviation 3. So x, y, z, this is your coordinate. X also follows normal 0, sigma square 9. Y follows normal 0, sigma square 9. Z also follows normal 0, sigma square 9. Okay. Now in order to represent a 3D, x, y and z, you need 3 independent variables. Alright. So now let's say you are choosing some point here. Okay. So now the probability that the distance between the point chosen and the target is your origin, let's say x, y and z. So this Euclidean distance you have to find out, and then find out the probability that the distance between the points chosen and the target exceeds 4 meters. So distance, how do you usually do? Distance is actually x minus 0 square plus y minus 0 square plus z minus 0 square. Okay. So this would be root over x square plus y square plus z square. Now you know the distributions of x, y and z. You have to find out the distribution of d and then find out the probability d exceeds 4 meters. Alright. Okay. So same thing with t distribution and f distribution. So t is actually a standard normal distribution divided by root mean of the chi-square distribution. This is Tn. Okay. So if x
Excuse
follows,
ma'am.
yes.
Can you please elaborate the last question? Like, how do we proceed?
The last question, I have given you a hint. This is a similar question is given in your assignment. So just try to solve it. If you can't, I'll discuss in the next question, class.
Ma'am, but till then the due date would be
I know,
over.
but I'm not allowed to discuss assignment questions as such. So I just gave you a hint. Okay. So try to solve it. You have x, y and z distributions given. You just have to find the distribution of the square terms. Alright. Okay. So as I was saying, the t distribution is actually a ratio of two independent distributions. If x follows normal 0, 1 and y follows chi-square n independently, then x by y by n square root, this is actually your Tn distribution. This is the relationship between t normal and chi-square. Okay. And t distribution is also symmetric. Okay. This is symmetric about 0. So probability T16 greater than 1.8 is actually the same as probability T16 less than minus 1.8. Why I am telling you these is because suppose you are given this value in your exam, but the question asks something like less than minus of this thing. So then you have to exploit this symmetry property and get to the answer. Alright. Okay. So these are some similar questions. And also F statistic is actually a ratio of two independent chi-square distributions. Okay, so if x follows chi-square m and y follows chi-square n, then x by m by y by n, this follows an fmn distribution. Okay, and also fmn is actually 1 by f in m. This also holds. And to find out this, the syntax is similar. PF Q1.3, DF1 will be 8, DF2 will be 16 and lower dot tail would be true. To find out greater than, the same thing, lower dot tail would be false. Okay, and since these are continuous distribution, T, F, chi-square normal, it doesn't matter whether you have less than equal to here or greater than equal to here. It doesn't really matter, but it matters if it is a discrete case. Alright, in discrete case, probability x greater than 4 if it is given, then you can directly type lower dot tail equal to false with q equal to 4. But if greater than equal to is given, then you have to give q equal to 3 if you want to give lower dot tail equal to false. Okay, so be very careful about this distinction between discrete and continuous random variables in a discrete setup. Okay, alright, so I think I'm almost done. Any questions do you have from today's session? Okay, and if not anything, I'm going to close the session now, and I'll see you next week. Thank you so much for joining.
Excuse me, ma'am.
Yes, yes sir,
Ma'am, I have a question.
yes.
मैम जो एडजस्ट करते हैं हम जब हम z टेस्ट लगाते हैं बेसिकली नॉर्मल डिस्ट्रीब्यूशन उसमें जो हम एडजस्ट करते हैं व्हेन वी हैव लेस दैन इक्वल टू साइन और ग्रेटर दैन इक्वल टू साइन सो दैट इज बेसिकली इन केस व्हेन देयर इज डिस्क्रीट डिस्ट्रीब्यूशन like I'm not clear on that concept.
Okay, let's say x follows your binomial 10 half. Okay, now probability x less than equal to 5 if you want. This should be probability x equal to 0 plus probability x equal to 5. One way out is you do a d binom for each of the x's and then add it up. Second way out is you do a p binom. Okay, you supply all parameters. In the q column, what do you supply? P, 5. And by default, if you don't supply anything, lower dot tail equal to true. This is going to give you the exact same answer. Now, if you want probability x greater than 5, and then if you write p binom q equal to 5, lower dot tail equal to false, this is going to give you incorrect answer, because greater than 5 lower dot tail equal to false, this is also going to give you a correct answer. Alright, probability x greater than 5. But if you have probability x greater than equal to 5, then if you write p binom q equal to 5 lower dot tail equal to false, then this is incorrect. If you have greater than equal to 5, then you have to put q equal to 5 minus 1. If you put 5 over here, this is incorrect. But if you put, instead of 5, if you put 4, 4 is correct. Why this happens? It's because R by default, if you give lower dot tail equal to true, it is going to calculate probability x less than equal to x. And if you give lower dot tail equal to false, then it is going to calculate probability x strictly greater than x. Okay, now if you have a discrete distribution, probability x greater than 4 means 5, 6, 7, 8, 9, 10. and probability x less than equal to 4 means 1 2 0 1 2 3 4. Alright, this thing and this thing you are going to readily get from the software. But if you have probability x greater than equal to 4, then what you actually need is you need 4 along with this, right? So that you can only achieve if you get probability x greater than 3. X greater than 3 with lower dot tail equal to false is going to give you x 4, 5, 6, 7, 8, 9, 10 and so on, if it is a discrete case. However, if it is a continuous setup, the point probabilities are 0. So probability x greater than equal to x is actually the same thing as probability x greater than x, because this probability x equal to x, this part will be 0 for continuous case, but this will not be 0 when your variable is discrete. Is it clear now?
Actually, I was asking about that continuity correction that we use, that minus half and plus half.
Oh, okay, that is approximation. Normal approximation you were talking about.
Yes, ma'am. I don't know what do we call it.
Yeah, okay, that one. Alright. So, if you have a, I understood. Let's say you have a binomial distribution NP and N is large. This thing, right? So then you are something probability x greater than some x, so that thing you are writing as probability x minus np by root over npq greater than x. But here you are using some adjusting criteria. This is what you were asking, right?
Yes, ma'am.
Alright. So what actually happens is that binomial, if you see binomial, your it will be bars like this, symmetric. Okay, and then we are approximating this binomial by a normal curve which would actually pass through, let's say, these midpoints. Okay, and that this would be the normal approximation. So you see, whenever I am approximating something like this with this thing, usually what we do, we fit it through the midpoints of these bars. So in order to adjust for that, we use that 0.5 adjusting factor.
So basically, whenever we have an equal to sign, like less than equal to or greater than equal to, then we use it. Otherwise, we do not.
No, even if we have less than oh, okay, yes, yeah, well, otherwise we do not. Are you sure we do not use for otherwise?
That's what I'm confirming, ma'am.
Okay. Actually, whenever we use that, we actually use it whenever we are doing any sort of approximation of binomial to normal. Okay, I think we use it even if it is greater than or less than, but I am not very sure. Please give me this week, I'll just figure this out and be more confident and get back, okay? But as far as I know, we use this for even greater than and less than, okay? But I'll definitely get back to this. I'll look at it and I'll get back,
Okay, ma'am.
okay? Thank you so much.
Thank you, ma'am.
Okay. Okay, so if there's nothing else, I'll just close today's session. Thank you so much for joining, sir. I'll see you next week.